Hi everyone. Thank you so much for joining me today. I hope you're having a great time at the conference. In today's session, we will be talking about extending your SQL applications to the edge using Azure SQL Edge. I'm Vasiya Krishnan, or Sia, and I work as a program manager for the Azure SQL Edge team in Microsoft.
Hi, good morning, good afternoon, good evening. I hope you are having a great time at this conference. My name is Sourabh Agarwal and I lead program management for Azure SQL Edge. And I am excited at the opportunity to spend the next hour or so talking about Azure SQL Edge and the capabilities the product offers. Folks, give me a minute. I'll share my screen and then we'll get started with the demo. Right, so you guys should be able to see my screen. At this point, you would probably see the Azure Data Studio up and running on my screen, but we'll get to Azure Data Studio in a bit and the actual execution of the full demo. But before we start with the execution, I wanted to take a few minutes and talk about the scenario which we are representing as part of this demo. Right. So if you have seen and if you have worked in the manufacturing industry, you would have seen, or actually not just manufacturing industry, almost every industry verticals where you deal with machinery. There are times when you would want to understand if a particular machinery is expected to fail or not, or ideally you would want to know beforehand if there is a chance for a machine to fail, and if the machine is expected to fail, what are the actions you can take to fix that problem, right? So that it does not hamper production, it does not hamper actual execution or business, business execution, right? So as part of this setup or as part of this demo, what we will do is talk about, or we'll create a setup for predictive maintenance of machine components. Now, to run this entire demo, there are a few things which I have created upfront, and I'll talk about that in a minute. So, and then there are a few things which we will walk through as part of this demo, right? So the first things first, let me go back to my Azure portal. So there are a few Azure resources I have created, which I wanted to use as part of this demo. The first Azure resource which I have created is called an Azure IoT Hub. The reason I have created the IoT Hub is because Azure IoT Edge is a subcomponent of IoT Hub, and you can register your edge devices as a device to the IoT Hub and then use the mechanisms provided by Azure IoT Edge and IoT Hub to do message exchange between devices, the cloud, and so on and so forth, right? For the purpose of this demo, we will use the Azure IoT Edge architecture to set up my predictive maintenance IoT setup, right? Now, I could have done this whole thing using Kafka also. And by towards the end of this session, we will share the GitHub repository where you can go and pick up the Kafka scripts also, but we'll get to that later, right? The second thing I have already done is created a virtual machine in Azure. Now, this is just for ease of usage. I could have used a physical device on, in my office, or I could have used a VM on my laptop or whatever it is, right? At the end of the day, I have created a machine which will act as my edge device, right? That machine could be a physical device, it could be a VM on your laptop, it could be a VM in the cloud. And given it cloud makes it easier for deployment, I just created a VM in the cloud. Now, before, so the one other thing which I've done upfront is I have in my IoT Hub, I have registered an edge device called demo device with, so essentially I have registered this Azure VM I created as an edge device to my IoT hub. Now, what this does is it pushes down the Azure IoT Edge components down to the edge device. And once those components are up and running, I can go ahead and deploy my SQL Edge, my data generator modules, and all of that to run my demo. Okay? So let me just quickly show you what I mean by what happens when we push the. So if I run this command on my VM, there are two containers running on my VM right now. One is the Edge Hub and the other one is the Edge Agent. These are components pushed by the Azure IoT Edge runtime when this device is registered with IoT Hub as an edge device. Right? Edge Agent is basically what controls and manages the IoT environment or the edge environment, and Edge Hub is what provides messaging services for the whole setup. Right? Okay, so that's all set up, right? Now, so a quick thing. So there are a couple of online docs available, which allows or which you can follow to set up an IoT hub, register an IoT edge device, and then enable IoT edge or Azure IoT edge on those devices. Right. So the two documents I was referring to is one is a quick start, which will walk you through the entire step from the beginning, that is creating an IoT hub, registering the device, installing the IoT hub, runtime, and so on and so forth. Right. This uses Azure CLI and PowerShell to create the components for you. And this other document is all about if you already have the device and you don't want to use, let's say, or you don't want to create a VM in Azure, let's say you want to just run or you want to configure your laptop as an Azure IoT Edge device, right? You can follow these steps to configure your local VM or your laptop or your physical machine as an IoT Edge device. Okay, right, so that's the setup part of it, right? The next thing we'll talk about is the data generation module. Now, if you remember, I was saying earlier that this whole demo is built on the concepts of machine telemetry, and we will collect machine telemetry data to do predictive maintenance or to predict if maintenance is required on a machine or not, right? Now, so for the purpose of this demo, I mean, since I don't have a physical machine where I can collect telemetry data from, I wrote a C# IoT Edge module, which can generate this data for me. Right now, this module is available on the GitHub repository. We will share towards the end of this meeting or this session. Right. So, what does this module do? So, at the at the core of it, what this module does is it sends out data for, or it implements a mechanism where we are generating data for 5 different machines. Now, what kind of data are we generating? The data we generate is pretty simple. So we have the machine ID, we have the timestamp associated with that. The timestamp as to when the data was collected. And then beyond that, we collect these 6 different parameters, which are voltage, the rotation of the machine, the pressure, the vibration, and then any error percentages which were encountered during the machine operations, right? And then all of this data is packed into a message and sent to my Edge Hub or IoT Hub, right? So essentially what this module will do is it will send a message to the IoT Hub saying that there is a machine telemetry data available, and let IoT Edge Hub or another module process that data, right? So this is basically just a message sending application which keeps on sending events or messages to the Edge Hub, right? So this is data for a particular, for one machine. Now, if I go back to the main core program or main function, what I'm doing here is I have essentially replicated this entire thing, and I'm sending out data for 5 different machines. So essentially, I am replicating it in a way that it ends up sending out data for not just one machine, but 5 events representing 5 different machines, right? And each machine data is sent out on its own channel to the Edge Hub. I've also done a few things to regulate the amount or the time difference between each message. So if you look at if I go back up top here, I am using a delay of 5 seconds between each message. So every 5 seconds, machine data is received. So for machine 1, we will receive messages every 5 seconds. For machine 2, we will receive messages every 5 seconds, so on and so forth, right? Now, so that's just the code part, right? Let's see this in action in a minute. So in my Visual Studio project, I can go and run and say, so there are a few options which we get as part of your Visual Studio setup, right? Or as part of your IoT project. You can run this entire thing in a simulator and see how it is working, right? To run the simulator, you would obviously need to have your Azure IoT Edge development tools installed on the dev machine or on your machine, right? And then what you can also do is generate a deployment template for your IoT Edge. Now, this deployment template basically it's a JSON file which defines how your modules will be deployed through IoT Edge, right? You can build or you can push the modules in form of a container to a repository to the cloud, or to your Azure Container Registry, or to your Docker repository, local Docker repository. Okay, so what I'm going to do is I'm going to first run this tool or this module in a simulator. Right, so this started. Now, what you would see is in a few minutes, you would see the modules getting initialized. It will initialize 3 different modules. The Edge Hub, so if you can see here, it is pulling the Edge Hub dev module. Then it will initialize the Edge Agent module, and then it will initialize the telemetry data module. Now, once the telemetry data module has been initialized, you can see the telemetry data being generated by this module. So running it in a simulation or in the simulator mode allows me to check if there are any issues with the code or not. In my case, I can see that this is all working fine, and I don't need to. I mean, there is no error as such. I can see that my machine telemetry data is getting generated every 5 seconds. So if I look at this data, this is for machine ID 1, and it was generated at 1441. This is GMT time, so 1441:02. Similarly, I have machine telemetry data for machine 1 at 4107, which is 5 seconds after, right? So my module is working fine. It is generating data, right? So everything is working fine in the simulation mode. Okay, let's go ahead and sorry. Okay, let me go ahead and stop the simulator. Right, so next thing what I'll do is, as part of my this thing is, I will build and push this module as a container to my Azure Container Registry. Now, what I had also done is beforehand, I have created a Azure Container Registry where I will push this module to, right? So let's go ahead and do that. Right, so it will go ahead and so if you can see, this is the location where my module gets pushed to, right? So my Visual Studio project will build, it will push the module up to my container registry. Now, The benefit of having the module or the container or the image in the container registry is that you can then use it in any of your development environments or any of your environments. And as long as the edge machine has access to and can connect to the container registry, you should be able to pull your modules from there, right? So let's do that, and let's wait for that to complete. It takes about a few. Okay, that's good. So this completed in quick time. So my modules was pushed. Now, once my module has been pushed to the container registry, what do we do next, right? So the next thing we'll do is we will set up this data generator module as a IoT edge module and deploy it on the edge device, right? So let's go back to my portal and go to my IoT hub, right? Uh, go to IoT edge and then on my demo device. Now, this is the digital representation of my edge device, right? Which I had showed you earlier when I connected to the SSH connection, and I showed you sudo docker ps command, right? Where edge hub and edge agent were running. So now next, what I will do is go and run the run the data generation module in the or deploy the data generation module to the edge device, right? Now, to deploy the data generation module, the one thing I had to do was provide credentials for my Azure Container Registry such that my edge agent can connect to the container registry and pull the image to initialize the data generator module, right? So let me go ahead and do this. So the URL which we will use is this one. This is where my image was pushed to, right? Okay. So sorry. Let's call this telemetry data, the module name, right? Now, I will leave the restart policy to always. That is essentially edge agent will restart the module if it sees that the module is failed. I'll run the desired status as always running and leave it as is. There are no other setup or settings to be set for this module. So we'll just go ahead and click on add. We'll do next for the timing. I'll come back and talk about the routes in a minute when we deploy SQL, right? So this is it, right? And just go ahead and click on create. Now, when you do that, edge agent, if you go back to my edge device, and let's say I run this command to see the logs for my right. So you can see that what my edge agent is doing is it is creating the telemetry data module. It will pull the image for the module, and then it will start the telemetry data module. Now, by now, it would have done that. And you can see my telemetry data module running up and running on the edge device, right? And if I go back to this, or if I look at the logs for this module, you can see that I have new messages getting generated for the module, right? So at this point, I have my data generator module up and running on the edge device. So I have machine telemetry data coming from my edge or coming to my edge device. Now, the next thing we will do is we'll deploy SQL, right? So to deploy SQL, we'll follow the same mechanism. We'll go to the portal, go to the device, go to the set modules tab, and then from there, we'll go to marketplace module and pick up so will pick up the Azure SQL Edge module. Now, once you deploy the Azure SQL Edge module, you will see this message, which basically means that there are some configuration options which we have to set for the SQL Edge module to work fine, right? So it will auto-populate the location of the URL and all of that. The things which you need to set is in the environment variables. So the first thing you will need to set is the SA password or the sysadmin password for SQL, right? If you are familiar with SQL Server, the sysadmin is the overarching account in SQL which has all the system server permissions, right? So I have set my sysadmin password. Then the other things which are already auto-populated are things around how the port mapping on the SQL Server to the host work, where will be the data files for SQL Edge placed, and so on and so forth. If you want, you can make changes to this. Like for example, I like to change my default port from 1433 to 1600 or whatever number, right? I generally don't keep my default port the port as the default 1433 port number, right? So I'll do that. I'll update it, and my SQL Edge is now ready to be deployed, right? Okay, so let's go ahead and run that, right? Now, right, so you can see now that SQL Edge is now up and running. If I go to my, if I check my modules on the machine, I would see that SQL Edge is up and running, and I have all the details available over here, right? Now, so once I have deployed SQL Edge, let's go ahead and connect to it, right? So I have already saved the connection string, and we can look through the connection string in a minute. But essentially what I'm connecting to is the machine IP port number 1600, which is what the host port SQL was configured to map to. So I am connecting to port 1600 on the edge machine. Okay. So at this point, my SQL is plain vanilla SQL, right? There is no data, there is no database, nothing in the SQL deployment, right? And obviously, none of my machine telemetry data is coming into SQL, right? So the next thing we will do is we'll create a database and some tables for the machine telemetry data to come in. Now, before I do that, let's connect to my June 9th. So this is my credentials and all that. Let me just go ahead and connect to this. Okay, perfect. Now, before I start creating the database and all of that, I just wanted to quickly show you a few things. So as you can see from my SQL Edge or the error log output, I am running the Microsoft Azure SQL Edge version of the product, or the latest version of the product. I am running this on a 4-socket machine, sorry, 1-socket machine with 4 cores and 8 logical processors, which means a total of 8 logical processors. And I am running this on a machine with some 26, 27 GB of RAM, usable RAM, right? And then the rest of the stuff is all allowed. What is the configuration of the databases, how the database is started, and blah, blah, blah. We'll skip that part, right? Okay. Right. So let's go back to creating my databases. Right. The first thing I'm doing here is I'm creating a new database called predictive maintenance, which will have all my tables and everything, and for the machine telemetry data. Now, the script looks a bit complex, but essentially what I'm doing is I'm checking if the database already exists. If it does not, you go ahead and create the database, right? And I'm creating a database of 1 GB size with a max size defined for 20 GB and a file growth for 1 GB, right? So essentially, I'm creating a database which could potentially be 20 gigs in size. I mean, that's just a number, right? You can create your database, whatever file size or limits you would want or you'd like, right? Right, so we'll take let that run. Perfect, so it took about 13 seconds to execute and my database is now ready, right? Now, this is interesting thing, which is a new feature in SQL Edge, and I'll talk about that in a bit when I talk about the table, right? Now, but just for a quick this thing, data retention is a mechanism which allows SQL Edge, or when you configure data retention on a table in SQL Edge, what it essentially allows you to do or allows the engine to do is look at your the retention policy set for the tables, and if there are or if there is data in the tables which is older than the retention policy you set, we can go ahead and truncate that data or remove that data from the tables. So the reason why this feature exists in SQL is because in an edge environment, right, your storage is limited, right? You do not want to be in a scenario where, because of all the data you are collecting and processing, you are running out of storage, right? So it would make sense for you to be able to delete data which is already been processed, and you no longer need that data, right? So this mechanism is basically instead of you as a user taking action and deleting that data every few, let's say, days or hours or whatever that is, this lets the engine do that work for you and delete that old data. Right, so let me go ahead and run this. Right, so once that is done, I'm going to use my database and start creating some tables in the database. Right, so first things I will create is a encryption key. This will be used at a later point again, but so the first table I'm creating is a table called machines. Now this machines is basically a placeholder table which tells me the machine ID, the make and model of the machine, and when that machine was purchased, right? Which is a typical thing, any inventory or or typical data you will see as part of inventory for any place where you have machinery operating, right? Right. So that's that. Then the second thing, our second table which we are creating is called a maintenance table, which basically tracks when the machine was last serviced and what component of the machine was last serviced, right? Now the third table I'm creating is the telemetry table, right? If you remember, this is the table, or this, if you look at the structure of this table, you have time, machine ID, voltage. This is the table where my data generated from the telemetry data module will come in, right? Now this table has a data retention feature enabled, and it has the filter column, or the column on which my retention policy is based, set to the timestamp table, and a retention period of 1 day. Now what that means is, as I said earlier, we will delete any data which is older than 1 day from this table whenever the background thread runs and cleans up, or runs and does the cleanup, right? So this guarantees that at any point I will not have more than a day's worth of data uh, in the table, right? That essentially limits my requirement for storage. Okay, so let's go ahead and create that table. right? Okay. Okay, I did run this. Perfect. And I'm creating a clustered column store index on my telemetry table because I want to further optimize the storage and query execution on this table. There are two more tables which I'm creating. One is called a models table, which is basically a storage for my predictive maintenance models or ML models, which I will use to predict if a failure will happen on this machine or not, right? So these are just placeholder tables. Okay, this one is another table I'm creating called machine anomalies. Now, what this machine anomalies will hold uh, is essentially a form of the telemetry data generated by the telemetry module, but data which has already been processed as part of my streaming engine or as part of my streaming operation. I will talk more about what that streaming operation is in a minute, but for the time being, let's just create the table and we'll then move forward, right? Okay. So now that all of these tables are created, I'm going to create some placeholder uh, data for my machine table and maintenance table. Essentially, what I'm doing is I'm adding some random machine values, essentially machine 1, 2, 3, 4, 5 with some random make models. And I'm also adding some random maintenance days for the machine. The theory is that, or the idea is that, given a specific maintenance day or given the last maintenance day for a machine and a component of that machine, we should be able to predict if there will be a failure for that component or that machine or not, right? This should take about a few seconds, I mean, 10, 15 seconds. Okay, so it took about, oh, actually it was much faster, which is good. Right, so I have all of my tables created, right? Now, while I do have the tables created, I am not, we don't see the data, or if you go and run a query against the tables, you won't see any data in the tables. So let's go ahead and do that for a minute, right? I just want to show you this. So if I go ahead and run a query against my telemetry table, there is no data in the table, right? Now, that's because we haven't yet created the mechanisms which will allow us to get the data from the telemetry module to the SQL module, right? So that's what we will go ahead and create now. Now, so if you remember, Sia was talking about streaming being available in SQL Edge, right? By as a new functionality in SQL, right? Now, what we are going to do, we are essentially going to make use of that streaming functionality, where we will stream the data from Edge Hub to my SQL. Now, if you remember the simulator output, right? My telemetry module was sending the data to Edge Hub. And now that the data is available in Edge Hub, SQL can go and read that data from Edge Hub and store it in the database, right? So let's go ahead and do that. So I'm just creating some command or some format specifications needed for my data. Okay. So the first thing I created was a file format. The second thing is a data source, which essentially tells me that we will go read the data from the Edge Hub. The third thing we will do is create a stream, which is basically telling me that my the source for the stream is Edge Hub, and then the location is the machine telemetry input from Edge Hub. Okay, so let's go ahead and do that. Now, once I've created that, the next thing for the streaming is we will create the outputs for the streaming, right? So the first step, I created the input for the stream. The input for the stream is Edge Hub. What will be the output? The output will be a SQL table, right? Okay, so let's go ahead and create the outputs for streaming. So this two are straightforward. Now this is where it is interesting, right? So the first output I'm creating for my stream is my telemetry table, which will get the raw data from the Edge Hub. Right? The second output I'm creating is for a machine anomalies table, which I had created. Now, if you remember, this is the table where we will store anomalies data for the telemetry data coming in from the telemetry module. Okay, so that's done, right? So I have created the input and the output for the stream. Now, the next thing we'll have to create is what we call as the stream query or the stream job. What that essentially means is that it's the mapping of the input to the output. How does the input fields map to the output fields, and are there any transformations which we would want to do as part of the input output, right? So this is where things get a bit interesting. So the first query, so this is a pretty big query, you will notice, right? The first part I am doing, there are two parts to this query, or there are two steps in this query or in this streaming job. The first is where I am transforming the input data from the stream to land in my machine anomalies table. Now, to do that, what I'm doing is I'm capturing the data from the stream into a tumbling window of 10 seconds. Right? So that every 10-second window of data is taken and that data is processed. Now, in that 10-second window, I go and check if there was any anomaly detected in the pressure and voltage or readings from the, pressure and vibration readings from the machine telemetry data, right? And then once I have done that anomaly detection, I insert that data into my telemetry anomalies, which was the machine anomalies table, right? So that's the first part of the stream job. The second part is where I am dumping the raw data into the machine telemetry table, which I had created earlier, right? So let's go ahead and create this streaming job. Okay, now, so I have created my streaming jobs, right? So if I go and check my tables, I should see some data coming into the tables, right? But I don't. So there is one critical piece which is missing, which we haven't done or I haven't done yet, is configuration of the routes, which will basically tell IoT Edge Hub how the messages from the telemetry data module needs to be routed to the SQL module, right? So to do that, let's go back to my Azure portal. Click on set routes and set modules, and then click on the routes part, right? So what I'm going to do is, let's take this, right? So the first thing I'll do is give some name, right? Let's call it let's call it machine 1 telemetry to SQL, right? Now, so this is auto populating, which is good, because what this does is there are two parts to this this route, right? Let me actually pull up a notepad and talk about what these two parts are. Right, so there are two parts. One is the from part, which is basically my source of the message. And then the second part is the, the target of the message. So what this route is telling my IoT Edge Hub is that messages from the telemetry data module and the output machine one needs to be routed to Azure SQL Edge module input machine telemetry. And that was the input we had created earlier as part of the streaming input definition over here, right? So this becomes the route for the sorry, what was it? Route for uh, my bad, sorry, route for the messages to be brokered or to messages to be routed from the telemetry module to the SQL module. Okay, let's go ahead and put this here. Right. I am not going to do anything in terms of the priorities and all of that. Uh, let's just go ahead and review and create. Now, before I review and create, I want to show you a few more things or a couple of other things before we go ahead and hit create. Right. So here, let's say if I go back to my SQL module, right? So this is the latest log from my SQL Edge module, right? Now over here, you see these metrics which are being listed, right? This is essentially the metrics from my streaming engine or the streaming engine, which is part of SQL. Now what you see here is that everything is zero. What it basically means is that my streaming is, or my stream engine is not reading any data and it's not outputting any data, right? But once we go ahead and create this route and we have the message, route established, we should start seeing messages getting populated from uh, in the data or the telemetry data from the SQL Edge module. Okay, so this was done. Let's make sure that it is all said and done. Now, if you go and look at this, this stats gets outputted every minute. So if you give it a few seconds, last was 15, 10, 23. So 15, 11, 23 is when, or near about that time is when the next stats will be printed, right? And we would be able to see that there, or hopefully we'll be able to see some numbers represented as part of that output. So we'll wait for a few seconds while this happens, right? Now, in the meantime, while this happens, what I can also show you is the fact that if I go back to my SQL table now, I should see some data into the table, right? But if you look at this, it is only capturing data for machine ID 1. What happened to the data for machine ID 2, 3, 4, and 5, right? That's not there yet. The reason for that is because we did not create the routes for data for machine ID 2, 3, 4, 5. Okay, so this has been printed. So if you go and look at this data, right, you are seeing some numbers, non-zero numbers here, which basically means that my stream job has taken some inputs and some outputs, and it's able to create and convert those data and write to the tables, right? Okay, now before we proceed, let's quickly go ahead and add the routes for the other machine. So your route has to be unique. I will change this in such a way that all the data is getting written to the same input in SQL Edge. Right. So, by the way, this is not something you would need. I mean, you would be doing when you're running with Kafka, because yeah, I mean that setup is this is pretty specific to IoT Edge. Okay, so I have all my routes defined. Let's review and create, and then I should be able to see data coming in from the rest of the machine IDs into my SQL tables. So let's go back to my SQL tables and look at the data. Uh, Let me just do top 5. So yeah, if you look at the latest data, you can see the data from all of the 5 different machines in my telemetry module. Okay, so at this point, we have data coming in from uh, the telemetry module to SQL, right? So let's take do a recap of what we did, right? So far. So the first thing we did is we created a edge device, or we designated a device to act as my edge device and registered that device to our IoT hub, right? Now, once that was done, we created a IoT Edge module using Visual Studio, and that IoT Edge module is essentially a simulation for my data generation, machine telemetry data generation. We built that module, we pushed it to a container registry, and then from that container registry, we deployed that module to my edge device, right? Now, post that, we deployed SQL Edge, and then once the SQL Edge module was deployed, we connected to it using SQL Azure Data Studio. We created a few tables in the database. We created a streaming job, which will help us get the data from the telemetry module to the SQL module. And we are at a point where we have all the data coming in from the SQL table from the telemetry module to the SQL table, right? Okay, let's spend a few seconds talking about this data itself, right? So this is one, and the other one is I want to talk about is machine anomalies. Right, so the telemetry data is just the raw data which was getting dumped from the telemetry module to the SQL module or SQL Edge module, right? Now, the data here is pretty standard, right? You have the voltage, you have the rotation, you have the pressure, you have the vibration, you have the error frequency or error percentage or precision errors in the output, right? And you have this data continuously for every 5 seconds for each of the modules, right? 39, 44, 34, so on and so forth, right? Now, the important thing is this one, right? So, sorry, let me actually also do this. So if you look at actually, let me filter it by a particular machine time. That way it's easier to see. Let's say machine ID is 1, right? So the last 10 outputs for machine ID 1 in this table. Now, if you look at this table, right, or this output, all of this data, this is the actual pressure data as it was received from the telemetry module, blah, blah, blah. And then there is a score. This is the anomaly detection score for the pressure. If you go back to my streaming query, I was doing anomaly detection using the spike and dip function on pressure. And sorry, and anomaly detection using the change point function on vibration, right? Now, if I go back to my output, this is the score which it represents. Now, if you look at this data, what it is telling me is that there are two instances where the algorithm thinks that there is an anomaly in the pressure output for the data. Now, that's mostly because if you look at this data, most of the time the pressure is below, is close to 95 or less than or close to 95. But for the times when it got or identified as an anomaly, you see the pressure is mostly above 98 and 100. Right? If I expand this further to see if my theory holds, let's see. Right? So 95 and above, close to 96, rather 100, and then 101 again. Right? So it is capturing, or it is in a way detecting that a higher pressure of in the order of 96, 97 is an anomaly. Right? Does it hold true for my second machine also? We don't know. Let's see. Right? So for the second machine, it identifies similarly, but at a much lower scale. So, so essentially what this algorithm, the machine detection or the anomaly detection algorithm is doing is it takes the data, looks at the data as you have defined. In this case, I have defined the that I should look at the last 30 seconds of data to see if there is a potential anomaly in the output or not, right? And this is a continuously learning algorithm in the sense that it keeps on looking over the data. So this is the part where it keeps on looking over the data, where this is where it is saying that the accuracy should be 95% and 120 is the number of data points to look at or into before deciding whether it's an anomaly or not, right? So essentially, we have the idea behind doing this or using this function is to show that you can do anomaly detection or you can do some sort of analytics on the data as part of the streaming engine itself. That is, as the data is being streamed into SQL. You don't have to wait for the data to first land into SQL and then do analytics on top of that, right? Okay, so this is one, right? So I'll leave it at, sorry, before we move forward, let me just quickly create some other functions and views, which I will need in a few minutes. These are basically functions and views which will help me run an analytics or ML prediction on this data, right? Okay, so let me close this window. I don't no longer need this. Okay. Right, so I don't need to clean up right now. Right, so the next thing we will do is, now that we have the table or the data coming into my SQL tables, the next thing to do is to go and train a ML model, which will do predictive analytics on this, predictive maintenance analytics on this data, right? So for the purpose of the to save time and everything else, what I have done is I have pre-configured my ML script and everything, and I have pre-trained a model. I'll walk you through each and every step of the process I am taking, but I mean it's pretty straightforward, to be honest. So this is my Visual Studio Code, and I am opening my Python notebook in VS Code, which will allow me to run some predictive maintenance, right? Okay, so the first things first, what I'm doing is I am installing some Azure ML. So I'm using AutoML or Azure AutoML to train my model. I mean, this is a very simple scenario. in theory, you could be, or in reality, you could be using any of the ML tools out there to train your models, right? It could be PyTorch, it could be Tensor, it could be MATLAB, it could be anything, right? And then I import the modules which I will use for my execution. The next step is I create a training data set. So I am selecting the data from this table called training data set 3, which is let me actually show you the script for the table. So this is the script for the table, which is essentially what it does is it looks at my aggregated telemetry table, the view I had created. It gets the data from the maintenance things, and essentially what it calculates is this. The main thing it calculates is this, as in what is the time difference between the last maintenance of the machine to today's date. And then the other thing it does is what I call as a maintenance factor. Basically, it's just some random algorithm I used to come up with a number which can help us, in terms of our prediction. That maintenance factor is basically a multiplication of everything in the table divided by the log of the days component. I mean, as I was saying, right, this is something I cooked up for the purpose of this demo. In theory, your training data set and how you train the data could be very different, right? But let me go ahead and create this table, and then I can show you the output of this table to see what it looks like, right? Right, so let's look at this data. So essentially what I did is, as part of my training, or as part of this training data set table, so these are all the voltage mean and everything, which is essentially the mean of this data captured, or averaged over a period of time, right? Right, essentially, sorry, let me go back to this, right? Now, as part of my training data, what I did is I also added a table, a column called failure charts, which is basically what we will predict from the ML algorithm, right? Now, my training data set needs to have some failure chance 1 outputs for it to be able to tell us that, for the model to learn and see how failures can happen in the data set, right? So anyways, so if I look at this table output now, I have one output which says failure chance equals to 1, and then there are about 9 outputs which says failure chance equals to 0. So this is what is my training data. This is a very small set of data, but over a period of time, your training data set will increase and the accuracy of the model will also increase, hopefully, right? Okay, let's go back to my Visual Studio. So I get that training data, I do some quick massaging on that data, and I set up my AutoML experiment or workspace. And then I don't do anything else. I just split this training data into my x-axis and or the input and the output, which is basically the prediction output and the input. And then I run this data through my AutoML configuration, right? And once my model has been trained, I output that as a Onyx model. That's pretty straightforward what I do. And then Once all of that has been done, I insert that model into my SQL table, right? Now, I'll use a different mechanism to insert the table into, or the model into the SQL table. The mechanism I'll use is, I've already uploaded my model to the database, right? Now, what I'm going to do is, sorry, I'll take that model and insert it into my, or upload that model to my SQL Edge module. This is one another way of doing, making sure that your model can be inserted into the SQL table. So let's see. I have the trained Monix model, and this is an old model I had trained. Actually, before I do that, let me just quickly check the help on this. I don't remember the command, sorry. So right, so I'm taking the source file, which is the trained Onyx model, and then I will upload it to my SQL Edge container and to a specific path in the SQL Edge container, which I can then reuse. So if I go back to this machine, I already have the query which will allow me to upload this or take this file, but this is the path where I will upload the train model to. Right. Okay. So my model should be now in the SQL container. Right. So let's go ahead and run this and see if that works. Okay, so hopefully it did work. I can go and quickly run a query from models and see if that model is available. So that model is available in my SQL table right now. Right? Okay, so that said, now I have a model which is available in my SQL table. Let's go ahead and run some prediction on this data. Okay, so I have my predictive maintenance. So what I'm going to do is I will use that model as part of my T-SQL predict query and run a prediction on top of this existing data. Right, so let's see. And this should be pretty straightforward. I don't see. So this is now running prediction on the latest data, which was in the table at 15:30, which was basically 2 minutes ago. Right, and if you look at it, it's saying that there is a failure chance for machine ID 1. Right, so it's essentially predicting that my machine ID 1 could potentially fail in the next whatever number of days it is. Right. Right, so this is how you, this is just a quick example of how you would train a model, upload it to SQL, run predictions within SQL. Now, in my case, the model is pretty simple, but in theory, you could have a complex model which looks at 1,000 other things and runs the prediction on the data, right? So again, going back, you now have a ML prediction or ML model running against data which was captured in real time through the streaming engine, right? And this is on top of the already existing anomaly detection and similar other stuff you can do on the streaming data as part of the ingestion itself. Right.
Browse to our documentation and our at aka.ms/SQL Edge. And if you're interested in learning about how our customers are adopting SQL Edge and how they are using SQL Edge, the links are available on the page. Finally, before we wind up, a quick shout out to our friends at the Data Platform Summit, the SQL Data Geeks. And if you're interested, there are multiple ways on how you can win prizes. That's it from our side. Thank you so much for your time and the patience. Thank you.